What's poppin', dogs? Mr. Allen here. We're about to solve this wonderful rational equation here, and we're going to list any domain restrictions. Woo! Beautiful. Now, first things first, I got to factor my denominator so that I can find my least common denominator. This one right over here can be factored. It is going to be x times x plus 2 little GCF action. Beautiful. Now, my least common denominator, my D, is going to be, let's see here. I got to have an x. I got to have an x plus 2. Oh, and I got to have an x and an x plus 2. Looks like there we are. X times x plus 2. That is my LCD. And my domain restrictions, let's get those done right now while we're thinking of it. X cannot equal, well, it can't equal 0 because it would cause this one to be 0 and this one. It can't be -2 because it would cause this one to be 0 as well as that one. So 0, -2 are the no-nos. If that were to pop up in our solution, we'd say, hey, man, nuh-uh, extraneous solution. Spoiler alert. I think we might have one of those here. I can see it in the future. Okay, so what do we got to do here? Some people like to get a common denominator for all my fractions, right? And then we can work with our numerators. I prefer to multiply both sides of the equation by that LCD of x times x plus 2, which then allows me to distribute it to each fraction here and then get rid of all my denominators because they're going to divide out, they're going to cancel out, whatever you want to say. All right, so I'm going to multiply this one by x times x plus 2. And I got to multiply this one by x times x plus 2. And I got to multiply this one by x times x plus 2. When I multiply both sides, it's got to be distributed to both terms here, right? And it is only being multiplied to my numerators, not the denominators as well, because really I'm multiplying by x times x plus 2 over 1. And in multiplication, our numerators and denominators get multiplied together. Cool? Awesome. So here, my x's are gone, and I'm left with, so this guy's gone, boom. And I've got 3 times x plus 2. Beautiful. This one, gone and gone. And I'm going to be left with x times x, which is plus x squared. And then lastly here, both of these guys are gone here. Whoop, whoop. Right? That's that original one right there. So I'm just left with equals +4. Wonderful. All right. Beautiful. Now what? Well, I guess I could distribute this 3 here. Yeah, that sounds fun. All right, so I get 3x plus 6 and then plus x squared equals 4. Ooh, looks like I'm dealing with a, I could have said this before, but a quadratic here. So the means of solving a quadratic, we often hit panic mode when we see a quadratic in our non-quadratic units. We're like, oh, I've never seen this before. I don't know how to solve it. You do know how to solve it. Go to like the back of your brain. You got to go way in the cobwebs, dust them off. We got to set this thing equal to 0. Factor, hopefully not the quadratic formula, factor and solve. Let's see if we can do it. I'm going to subtract 4. So I'm going to get, let's see here, x squared. I'm rearranging x squared plus 3x. 6 minus 4 is +2 equals 0. Beautiful. And now I'm going to factor what multiplies to 2 and adds to 3. That's going to be a 2 and 1, dogs. So I got x plus 2 and x plus 1. Now when I solve this, I've got x plus 2 equals 0 and x plus 1 equals 0. So I'm going to get x equals -2 and x equals -1. Before I circle these, I got to check my domain restrictions, which are right over here. 0 and -2 are no-goes. -2 would make my denominator equal 0. Both these bad boys right here. So my only solution is x equals -1. This is what's called an extraneous solution. Extraneous solution. That is fun. I do know how to spell it. Extraneous. That's an E right there, right? A word I can't spell. It's very big, and it impresses people when I can spell. So that's exciting. So, boom, extraneous solution. Fun fact: multiple choice questions, SAT, ACT, and maybe even your test will often say which of the following is an extraneous solution. All right, it's got to be our domain restriction from our domain restriction. But we don't know until we solve this thing if it does have an extraneous solution. So I can ask you, or the SAT or ACT can ask you, which of the following is an extraneous solution. You'd still have to go through the entire process and find out which solution ends up matching up with the domain restriction, meaning it cannot work, okay? So there we go. My only working solution is x equals -1. The other one's extraneous. That's awesome. That's dope. We've said extraneous a bunch of times. Feel free. I challenge you to use it in your daily language here tomorrow after you watch this video, and have a great day.